We on it. Biggie, 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 can't you see? Sometimes your words just hypnotize me. And I just love your flashy ways. This is why they don't think you're so fake. Biggie, biggie, can't you see? Sometimes your words just hypnotize me. And I just love your flashy ways. This is why they don't think you're so fake. I put in NY on the BKN Miami, DC, prefer my teach. All Philly, double skis on every cutie with the booty for the coochie. The real and who's really right? Break my pussy, stick on the next. I'm on the hand. Last tips if I want some. On blast, we that's what you like. That's how most of these so-called gangsters now. Rapping out some broad, trajectoire. Till they come from cars, still leave you on the pavement. Condo paid for, no call payment. That my payment, no for the payment. You know the style up in the Brooklyn basement. Basic like magic, that's how I stay true. Richer than rich, so you tell me think cool. Sometimes your words just hypnotize me. And I just love your flashy ways. That's why they don't think you're so fake. Can't you see? Sometimes your words just hypnotize me. And I just love your flashy ways. This is why they don't think you're so fake. I can feel you get real when you hit. That's cargo, my cargo, 160, split it. Working by everyone, you can run, you can run. I know you, so good as me, bread. Flow girl, steady, keep sleep like the wrist. So, Timothy, it's easy, girlfriend, again. Call me round again, come through, have my rough, that's first.
Folks, we had 6D. What number was this? 12 due this morning? Was that 12? Yeah. 6D12 was due this morning. They did give you the answers. What we're learning to do is actually take the initial step to using the formulas that we learned to write this unit. We spent a lot of time this year on nomenclature, having a formula, writing the formula. But now it is time to use these formulas. It is what we did on 6D12 is the preliminary step to many, many chemistry calculations. When you know the formula mass, when you know the mass of a substance, there's a lot that you can do with it. So that's what 6D12 was trying to tell us or teach us how to do. In many of the calculations, you may not really be using formula mass. Formula mass is the mass of one unit of the substance. For instance, one molecule or one formula unit of a salt. Very often in chemistry, though, we do use the molar mass, the mass of 1 mole of the formula. Essential calculation indeed. Now, one of the things that's difficult for everybody taking Chemistry 1 is understanding that the setup of the problem, the format that you present the problem in chemistry is essential. It is vital. It is perhaps the most important aspect of doing the problem. The answer in chemistry, many would argue, is not as important as the process to getting that answer. So what are we talking about? Let's take a look at this first problem here. In this first problem, we're calculating the formula mass of phosphoric acid, H3PO4. Now, folks, you do want your attention up here at this time. We don't want to be typing on our Chromebook. We don't want to be writing. We don't want to be doing anything other than locking in and watching what I'm about to explain to you. Here's why. Next 9 weeks, about 2/3 of the next 9 weeks will have what we're learning to do today as the first step. And if you do not quickly master what we're doing, you're going to miss virtually every problem we do next 9 weeks. So lock in, listen to what I'm saying, then tonight's homework assignment, you'll get another opportunity to practice it. So watch carefully what I'm about to say. It's the way we do it in chemistry. Now, the system of solving something like the formula mass, we call dimensional analysis. Some teachers call it factor labeling. This is the process that we go about solving the problem. Yes, it involves extensive amount of writing. Yes, it will take longer to set the problem up. Yes, many of you could get the answer to this problem in a matter of seconds. But you are rewarded handsomely in this class for doing the problem as I'm about to explain. So what are we really finding here? When they say formula mass, they're telling you what units they want you to use. They want you to find H3PO4. It is a covalent substance, as at least it starts covalent. It will break up into ionic. It's an acid. But they want a molecule. What is the mass of a molecule of H3PO4? In the middle of the molecule, we have the phosphorus atom. And then we have oxygens attached. We have oxygens attached to the phosphorus. And then we have 3 hydrogens attached to each of the oxygens. That's phosphoric acid. It's phosphoric acid because those hydrogens break off. They want the formula mass. They want the mass of one of these little molecules. Molecules do not have much mass. You wouldn't do this in grams. When they ask for the molar mass of something, then it would be in grams. A molar mass would be like the mass of 6.022 times 10 to the 23rd of these. That's not what they want. They just want one molecule. They want this on the order or scale of atoms. What is the unit we use to measure the mass of atoms or individual ions? That unit's called a what? Atomic mass unit. Very well. AMU. You guys remember that? That's outstanding. So how do we set this problem up? First thing, you put a heading to this problem. You would always write a heading telling whoever is looking at your work what it is you're finding. Like when you're in college and you're doing a lab, you tell the lab instructor or whoever's reading your lab report, what am I doing here? I'm determining the formula mass of H3PO4, the heading. Then we set it up. We would set this entire problem up. First, we need to know how many AMUs of hydrogen are on this molecule. Well, how many atoms of hydrogen are on this molecule? There are 3. And you would write atoms of hydrogen. Now, they call this dimensional analysis or the factor label method. It's called both things here. Dimensional analysis, when you learn to do it, it will set the problem up for you so that you can't make any mistakes. You use the dimensions or the units to guide the entire problem. You analyze the units, and it will set up everything. Dimensional analysis. Let me show you what I'm talking about. What am I trying to do? Formula mass. To find the formula mass, I need to know how many AMUs of hydrogen are on the molecule. Whatever I'm trying to find will go on the top of the last expression, the last equality in the problem. So in this case, I only need one equality or one conversion factor. It only takes one conversion factor to change atoms into a mass. Next week, when we start off the 4th quarter, we're going to do more than one conversion. When we get into the later part of the final 9 weeks, we're going to be doing multiple conversions of one substance into another substance, using this to solve for things regarding chemical equations. It's called stoichiometry. So AMUs, I'm trying to find the AMUs of hydrogen. That unit goes on top. You see this? AMUs of hydrogen. AMUs of hydrogen right here on top. Now, I'm not trying to cross it out. I accidentally crossed it out. AMUs of hydrogen are here. AMUs of hydrogen are here. I know how many atoms are on this molecule. How many atoms of hydrogen are on the molecule? There are 3 atoms of hydrogen on the molecule. Here's my atoms of hydrogen right there. Atoms of hydrogen go on the bottom. So if I know what I'm trying to find, those units are on top. If I know what unit I'm starting with, those units go on the bottom. The units tell you what goes where. It doesn't tell you where these numbers come from. And I've called this inequality. Equality means what is on the bottom is related or equal to what is on the top. It's a conversion factor. Inequality can be used to convert one unit, atoms of hydrogen, into atoms of AMU, or atoms of hydrogen into AMUs of hydrogen. This unit on top. This unit goes on the bottom. Where do I get these numbers? 1.008 AMUs of hydrogen in one atom. Where does that come from? Yes. That comes from the periodic table. If you look in hydrogen's box, somewhere in there you will see 1.008. Somewhere else in there you're going to see the number 1. The number 1 is the what of hydrogen? That's correct. It is the atomic number. That is how many protons hydrogen has. Anything with 1 proton and only 1 proton is hydrogen. And it turns out the hydrogen atom is 1.008 AMUs. What is an AMU? Yes.
It's the average mass of the atom. So, like, there's some atoms with like extra electrons.
Extra neutrons. Yes, extra neutrons. Now, that is a great explanation. That is a great explanation. Some hydrogen atoms have 1 proton, 1 and no neutrons. Some have 1 and proton, 1 neutron. Some have 1 proton, 2 neutrons. What are they comparing the AMU to? It is a relative scale. Yes. It is 1/12 the mass of what atom? Outstanding. It is 1/12 the mass of carbon-12. An AMU somewhere around the average mass, somewhere between the mass of a proton and a neutron. Which is why hydrogen's AMUs are at 1 and slightly above 1. Why? By and large, by a huge scale, most hydrogens only have 1 proton. That's why its AMUs are very close to 1. This is inequality. 1 atom of hydrogen, 1.008 AMUs. That's an equality. When you have an equality, if 2 things are equal to each other and you divide one by the other, if I divide one by the other, this says 1 atom of hydrogen equals 1.008 AMUs. If I divide one by the other, what does it equal? So let's divide both sides by 1 atom of hydrogen. What I do to one side, I can do to what? I can do to both sides. Yes? And when you have an equality, if I do it to one side and I do it to the other, I'm good. Right? So 1.008 AMUs of hydrogen. 1 atom of hydrogen over 1 atom of hydrogen would reduce to what? 1. It reduces to what? 1. 1 equals 1.008 AMUs of hydrogen over 1 atom of hydrogen. Are you seeing what's happening here? Are you allowed to multiply anything by 1 and not be in trouble? Yes. All I'm going to do is multiply 3 atoms by 1. I'm allowed to do that, but I'm going to disguise 1 by putting it in this form. This is just 1 cleverly written. 1.008 AMUs of hydrogen over 1 atom of hydrogen is 1. So instead of putting 1 inside this, I'm going to put this expression. It's 1. I'm just multiplying 3 atoms by 1, disguised differently. And that is a sexist term that we need to do away with. We should start a campaign. Girls do problems as well. We should not call this one in disguise because girls use the numbers too. It could be dis girls. Why don't we just call it dis peoples? Dis peoples or dis humans. Not dis guys or dis girls. We don't need to be sexist. Let's just love everyone for who they are and not what sex they are. Here we go. What happens now to my units? The numbers come from the periodic table. The problem, what I'm trying to find, what I'm given, sets up what number goes where. I have atoms of hydrogen right here, do I not? This is essentially, can't you put any number over 1? Yes, so I have atoms of hydrogen here and I have atoms of hydrogen there. I have them in the numerator and the denominator. What happens? If I have atoms of hydrogen here and atoms of hydrogen here, what happens to those units? They cancel out. They factor out. The other name for dimensional analysis is the factor label method. Why? I'm going to factor out those labels. Labels are a fancy name or another way of saying units. So this unit cancels with this unit, leaving me with the unit I'm trying to find, AMUs of hydrogen. 3 times 1008 is 3.024. Now, some of the students in the class might be saying, why am I using 1.008 instead of 1.00794? I would like you to use the numbers that are on the periodic table that we have posted in the class information section. Most of our atomic masses and molar masses are rounded to the hundredths place. For some of them that only have a few digits out front, they might go out to the thousandth place. But for the purpose of this class, we do not need to go out past whatever is on that table. That's just a lot of extra numbers to type in. We do the same thing for all of these AMUs of phosphorus. There's 1 atom of phosphorus in this molecule. There are 4 atoms of oxygen in this molecule. Now, here's where I want to caution Chem 1 students. When many, are you listening in the back? Many chemistry teachers, not all of them, many chemistry teachers are more concerned with what's happening up here than what is right here. On a semester exam, for instance, this problem alone could be worth significant points. Let me show you. 1 point for your heading. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45 points. Oh, 46, 47, 48, 49, 50 points. 50-point problem. Every time your pencil or finger touches the keyboard, pencil touches the paper, it is a point. So if you leave the units off the problem, you will fail that problem. The units, the headings, the labels are more highly valued in many chemistry classes than the actual answer. Yes.
Yeah, question mark on the side.
Could be a point. Now, sometimes I will give you a little bit of this. I might write the question mark for you. I usually write a few things in there, not necessarily because I don't think you can, but because it makes it easier for me to grade what I'm looking at. You see what I'm saying?
Yep.
So if I just say, here, solve this, and people start writing, stuff ends up all over the place. But if I give you like the bones of the problem, you're like, would you give us something like this and maybe this and maybe this so that you can see the flow? I might. What's the difference between science and many math classes that you take? Math class, the numbers are very important. The meaning of the numbers, what you can do with the numbers, very important. In science, it's the unit that follows the number that really, really is of great essence. This is how we do these kind of problems. When you finish the problem, you tell me what you solved. You see this says, what's the formula mass? Determining the formula mass. Determining the formula mass is what we're doing here. Bueno, si fuera, por favor. Oh, yeah. I don't know why it is the mouse gets lost on this thing all the time. It might be because the person using the mouse is lost. You see how we finish the problem? Formula mass of H3PO4. This is something you will do as well. You won't be given that necessarily. Dimensional analysis. Now, take a look at the next problem. On the next one, they're asking for the molar mass. What do they want in this one? What do they want in this one? Molar mass. What are we trying to do here? Molar mass. Very good. Molar mass is the mass of 1 mole. 1 mole is 6.022 times 10 to the 23rd of them. That is a lot. Like if someone said, would you let me pay you 6.022 times 10 to the 23rd to work here? And you'd be like, what am I doing? As long as it doesn't involve something illegal where I'm going to be in jail, I will do that. That would be a lot of money, 10 to the 23rd. We would probably be able to pay off the debt. National debt with 1 check. I didn't add it up, but I think we would. Here, we are talking about lots of them, enough of them that there is a cause for us to not use AMUs as the unit, but to use grams. But where did these numbers come from? Where did we get that there's 14.01 grams of nitrogen in 1 mole, and there's 16 grams of oxygen in 1 mole? Where did I get those numbers? If we look in nitrogen square, there would be like a 7 somewhere, and maybe a 14.01 somewhere. Is that where we got those numbers? I thought 1401 was the average mass of the naturally occurring isotopes of the nitrogen atom expressed in AMUs. Is that true? Yes. Well, then where are we getting grams for that? How can a nitrogen atom's average mass be 14.01, yet a mole of them is also 14.01 grams? The atom has an average mass of 14.01 AMUs, but a mole of them is 14.01 grams. Where did this number have 2 meanings? It has 2 meanings. It has a unifying characteristic to it. That number unifies the subject of chemistry and makes this periodic table one of the most useful documents in all of science. AMUs, what is it based on? An AMU is 1/12 the mass of what? Carbon 12. Oh, that should not be it. Carbon 12. It is 1/12 the mass of carbon 12. But what is the other definition of that number? It is the mass of 1 mole of nitrogen. Why is it the mass of 1 mole of nitrogen is the same as the average mass of the nitrogen atom? Answer. In AMUs, it's based on carbon 12. But what is a mole defined to be? The number of atoms in 12 grams of carbon 12. If I have 12 grams of carbon 12 on a balance, I have a mole. What will the balance say? 12 grams. What is the AMUs based on? 1/12 the mass of carbon 12. Wait a minute. AMUs are based on that number, and mole are based on carbon 12, and moles are also based on carbon 12. Since they're both based on carbon 12, it gives that number 2 meanings. Do you remember discussing that earlier this year? It was worth, do you remember we spent several days talking about the mole concept. It's time to refresh it, though. That's the beauty of chemistry. It all comes back again. So the only difference here, they're asking for a mole. Do we do the problem exactly the same? Yes. What's the only difference? The units. I'm looking for grams. Grams go on top. I'm starting with moles. It goes on the bottom. If I have 1 mole of N2O5, I would need 2 moles of nitrogen to make it. If I have 1 mole of N2O5, I would need 5 moles of oxygen. So these numbers are all the mole-to-mole ratios of the elements in that compound. They're also the ratios of the atoms in that compound. Any questions on any of this? You have an opportunity to practice a few more of these tonight. I believe it's 6D13. Look at the problem and look at the answer key carefully. Your numbers should match, your unit should match, as well as the symbol that that number and unit belong to. The label has 3 parts to it: a number, a unit, and what the substance is. Whether it's an individual element, an ion, or for that matter, a compound. Every number needs those 3 things. So check 6D13's key carefully. And then tonight, ladies and gentlemen, it's with great excitement tonight that you will have the opportunity to watch a video that will explain and show you how they know what the formulas really are. How do they know that dinitrogen pentoxide has 2 nitrogens and 5 oxygens in it? How do they actually know that? We are not like shrinking ourselves down to the size of atoms and going in and counting protons of every atom on a molecule. We're not doing that yet. I don't think we have something that can shrink us down to that size yet. So how do they really know dinitrogen pentoxide has 2 nitrogens and 5 oxygens? Tonight you will find that out. It could be one of the greatest videos you watch today after school for this class. I'm boastful, yes. But of all the chemistry videos we watch tonight, and there is one, it will be the best one we watch tonight. That's 6D14, isn't it? You're going to learn how they know.